Introduction to DNS topology. Welcome to our deep dive into designing DNS topology for Google Cloud Platform. Think of DNS as the phonebook of the Internet, but in a cloud environment, it becomes the phonebook for all your services, both public and private. Today we're going to explore how to create a seamless name resolution experience across your entire enterprise network. This is absolutely critical for service discovery, hybrid connectivity, and overall application reliability. We'll cover everything from basic cloud DNS fundamentals to complex hybrid scenarios where your on-premises systems need to talk to GCP resources and vice versa. By the end, you'll understand how to architect DNS solutions that scale and perform reliably. Cloud DNS fundamentals. Let's start with the basics. Cloud DNS is Google's scalable, reliable, and managed authoritative DNS service. It runs on the same infrastructure that powers Google itself, so you know it's built for scale and reliability. The fundamental concept here is translation. DNS translates human-readable domain names like www.google.com into machine-readable IP addresses like 172.217.8.100. In a cloud environment, this becomes even more critical because we're dealing with dynamic resources that can scale up and down. Understanding the difference between public and private zones is absolutely fundamental to any GCP network design. This distinction will determine how your services are discovered and accessed. Zone Types Overview. This diagram shows the key distinction between public and private zones. Notice how the public zone is visible to Internet users. They can query it from anywhere on the Internet and get back public IP addresses. The private zone, on the other hand, is only accessible from within your VPC network. When a GCP virtual machine queries for an internal hostname, it gets back a private IP address that's only routable within your VPC. This separation is crucial for security and network segmentation. Your internal services remain hidden from the public Internet while still being discoverable by your applications. Creating public zones. Public zones are your gateway to making services accessible from the Internet. When you create a public zone, you're essentially telling Google Cloud, I want to host the DNS records for this domain. The process involves creating the zone, adding your DNS records, and then updating your domain registrar to point to Google's name servers. This hands control of your domain's DNS to Google Cloud. Notice in the commands how we specify visibility as public, and how we get back name servers that we need to configure at our domain registrar. This is the critical step that makes your zone authoritative for your domain. Creating private zones. Private zones are where the magic happens for internal service discovery. These zones are only visible within the VPC networks you authorize them for. When you create a private zone, you're essentially creating an internal phonebook for your cloud resources. Applications can find each other by name instead of having to hard-code IP addresses. The key difference here is the visibility setting and the network's parameter. This tells Cloud DNS which VPCs are allowed to query this zone. Without being in an authorized VPC, you can't resolve these names. Hybrid DNS architecture. Now we're getting into the real-world scenarios that most enterprises face. You have got resources on premises and in the cloud, and they need to talk to each other. This is where DNS forwarding becomes critical. Think about this scenario. Your on-premises application needs to connect to a database running in GCP. Instead of hard-coding IPs, you want to use a hostname. But your on-premises DNS server does not know about GCP resources. This is exactly what DNS forwarding solves. We can configure your on-premises DNS to forward certain queries to GCP, and vice versa. Inbound DNS forwarding. This diagram shows the flow when an on-premises client needs to resolve a GCP resource. Follow the numbered steps carefully. This is a common exam scenario. The key insight here is that Google automatically assigns special IP addresses within your VPC to act as DNS forwarders. These are the targets your on-premises DNS server will forward to. Notice that this absolutely requires private connectivity, either Cloud VPN or Cloud Interconnect. Without that private network path, your on-premises DNS server cannot reach the forwarder IPs in your VPC. Setting up inbound forwarding. Here's the practical implementation. First, you create an inbound server policy in Cloud DNS. This tells Google, I want to accept DNS queries from outside this VPC. Google then automatically assigns IP addresses within your VPC range to act as DNS forwarders. You can see these with the Compute Addresses List command. Finally, you configure your on-premises DNS server with conditional forwarders. I've shown examples for both Bind and Windows DNS Server because those are the most common in enterprise environments. Outbound DNS forwarding. Now let's look at the reverse scenario. GCP virtual machines need to resolve on-premises resources. This is equally common in hybrid environments. The flow here shows how Cloud DNS can be configured to forward specific domains to your on-premises DNS servers. Notice how the forwarding zone acts as the decision point. It sees the query and says, this should go to on-premises. Again, private connectivity is essential. Cloud DNS needs to be able to reach your on-premises DNS servers over the private network connection. Setting up outbound forwarding. The implementation for outbound forwarding uses a special zone type called a forwarding zone. Unlike a normal zone which contains actual DNS records, a forwarding zone contains only instructions about where to forward queries. You specify the domain to forward and the IP addresses of your on-premises DNS servers. Then you authorize your VPC to use this forwarding zone. The test commands at the end are important. Always verify your DNS configuration is working as expected. DNS issues can be notoriously difficult to troubleshoot after the fact. Complete bidirectional hybrid model. Now let's see how everything comes together in a real enterprise environment. This diagram shows a fully integrated hybrid setup where we have seamless name resolution in both directions. Notice how we implement both inbound and outbound forwarding policies simultaneously. The on-premises client can resolve GCP resources, and the GCP VM can resolve on-premises resources. The table below the diagram is crucial for exam scenarios. It shows exactly which DNS configuration handles each resolution scenario. Study this pattern because it appears frequently in certification questions. DNS peering. DNS peering is a GCP native way to share DNS zones between VPCs within Google Cloud. This is different from forwarding. Unlike forwarding, where queries are sent to external servers, here we're sharing zones directly between VPCs. Think of a scenario where you have multiple VPCs managed by different teams, but they need to share a central DNS zone. Maybe your platform team maintains a shared services zone that application teams need to access. The key advantage here is that it's cleaner than DNS forwarding when you're staying within GCP. No need for complex forwarding rules. Just peer the zones directly. Split Horizon DNS. Split Horizon DNS is a powerful pattern where you provide different DNS answers for the same query depending on where the request originates. This is incredibly useful for optimizing network traffic and costs. Imagine you have an application at app.mycompany.com. External users should get a public IP that routes through your global load balancer. But internal virtual machines should get a private IP that routes through your internal load balancer, keeping that traffic on the private network. This saves you egress costs and improves performance because the traffic never leaves your private network. It's a common pattern in well-architected cloud solutions. Let's wrap up with some advanced concepts and best practices that will help you in real-world implementations and on the exam. First, understand when to use forwarding versus peering. Forwarding is for connecting to external DNS systems like on-premises, while peering is for sharing zones between GCP VPCs. Security is crucial. Always use private zones for internal resources and implement proper network segmentation. TTL values matter for performance and failover scenarios. For troubleshooting, always test your DNS resolution from multiple points and use tools like dig and NS lookup to verify behavior.